Welcome to The Explainer. We tend to think of learning as just trial and error, right? You make a mistake, you learn from it. But what if an AI could skip some of those painful mistakes? What if it could imagine a better way? That's what we're diving into today. This incredible idea of artificial imagination and how it's completely revolutionizing the way machines think. So let's get right to it. How does an artificial intelligence go from just reacting to things to actually planning for the future? How does it develop that kind of foresight, that ability to think a few moves ahead that's just second nature to us?
Well, it all boils down to a field called reinforcement learning. Honestly, the best analogy is training a dog. You give a treat for a good sit, and pretty soon, the dog figures out what actions get it the most treats. It's the exact same idea for an AI. The treat is just a reward signal, and the AI's entire goal is to figure out how to make decisions that rack up the biggest score, whether it's a robot learning to walk or a program learning to play a game.
Okay, so when it comes to this kind of learning, there are really two main paths an AI can take. On one hand, you have what's called model-free. Think of this as pure gut instinct, learning directly from raw experience. On the other hand, you've got model-based, which, well, it's more like being a planner, a strategist. Let's stick with that model-free idea. It's exactly like a kid learning not to touch a hot stove. They don't need a physics lesson on thermodynamics, right? Nope. They touch it once, it hurts, and a direct connection is seared into their brain. Hot stove equals bad. It's a super powerful way to learn, for sure. But man, it relies on actually getting burned a few times. But here's where it gets really cool. What if the AI didn't have to get burned at all? What if it could build its own little mental sandbox, a cartoon version of the world inside its own code, a place where it could play out different scenarios, a what-if machine to test things without any real-world consequences? This is where we start talking about AI imagination. And that's the absolute core of the model-based approach. It's kind of like a four-step dance. First, you act in the real world and gather some experience. Second, you use that experience to update your internal map of how the world works. Third, and this is the key, you plan by running a ton of simulations inside that model. You daydream. And fourth, you take what you learned from daydreaming and use it to make a much smarter move back in reality. It's this beautiful, continuous loop of acting, learning, and planning. Chess is the perfect example of why this is so unbelievably powerful. I mean, the number of possible chess games is it's bigger than the number of atoms in the known universe. Seriously. There's no way an AI could ever memorize the value of every single board position. But the model for chess, the rules for how the pieces move, that's dead simple. You could write it on a napkin. And that simplicity is everything. Because the AI knows those simple rules, it doesn't need to memorize anything. It can just look ahead. It can explore these massive branching paths of possible futures. We call this a tree search, and it's way, way more powerful than just remembering games it's played before. This is the engine of AI planning. Okay, so this model-based thing sounds like a superpower, right? An AI that can literally imagine the future. But hold on, because there's a huge, huge catch. What happens when your imagination is just plain wrong? Yeah, this is the Achilles heel of the whole approach. The AI is only as good as its model. If that internal cartoon version of the world is inaccurate, then any plans it makes based on that cartoon are going to be wrong too. It's garbage in, garbage out. It's like trying to navigate a city with a map that shows a bridge where there's now just a giant canyon. Your plan is going to have some issues. So you've got this classic dilemma. Real experience is 100% true, but it can be painfully slow and expensive to get. Simulated experience is super fast and cheap, but it might be based on a flawed model. So, of course, some really smart people came along and asked the obvious, brilliant question, why can't we have both? And this is where a concept called the Dyna architecture comes into the picture. It's a breakthrough idea that basically says, let's learn from everything. The AI learns from real experience as it happens, but in between real steps, it also learns from millions of imagined trials that it runs inside its own head. It's the best of both worlds. And the results are just, wow. Look at this chart. In a simple maze, a regular model-free agent, the one with zero planning, took 30 attempts to solve it. But a Dyna agent that did 50 imagined planning steps for every single real step it took, it solved the maze in just 3 tries. That's a 10-fold increase in speed. It's squeezing so much more learning out of every single interaction with the real world. So being able to learn from both real and simulated experience is a total game changer. It's not just an improvement, It gives the AI a planning superpower. Which, of course, leads to the next question. Just how far can we push this? How powerful can this AI imagination really become? This brings us to one of the coolest sounding algorithms out there, Monte Carlo tree search. And yes, the Monte Carlo part is exactly what you're thinking. It's named after the casino because it uses randomness in a really clever way. This algorithm, this was the silver bullet for cracking what many considered the grandest challenge for AI, the ancient, beautiful, and mind-bogglingly complex game of Go. So how does it work? You're gonna love this. The core idea is almost comically simple. Instead of trying to analyze every single possible move in Go, which is literally impossible, the AI just plays a random game against itself, all in its imagination, all the way to the end, just to see who wins. And then it does it again, and again, and again, thousands of times every single second. It's just this whirlwind of imagined games. And with every single simulation, it collects one tiny bit of data. When I started with this move, I won 60% of the time. It's just building up statistics on which moves seem to be winners. But here's the magic. It's not just random forever. The AI learns from its own imagination. It starts to notice, hey, these branches of the future seem to lead to a lot of wins. So it starts to focus its imagination, spending more and more of its simulation time exploring the paths that look the most promising. It becomes a smarter searcher as it goes. And the impact of this was absolutely revolutionary. I mean, for decades, computers were just awful at Go. Top pros could give the best programs a massive handicap and still win easily. Everyone thought Go required some kind of deep human intuition. Then Monte Carlo tree search comes along, and by 2016, a system called AlphaGo, built on these very ideas, defeated Lee Sedol, one of the greatest players of all time. It was a landmark moment for AI. So let's just step back and look at the big picture. Giving an AI an imagination, this ability to build a model and simulate the future, is completely transformative. It makes learning insanely more efficient. It enables this incredibly powerful, focused kind of planning. And it turns problems that we once thought were totally intractable into problems that a machine can solve. And that leaves us with a pretty profound final thought, doesn't it? If an AI can learn to imagine its own future, to plan and strategize with this incredible foresight, what does that mean for our future? As these systems get even better, how is that going to change the world that we all share? Something to think about. Thanks for joining me on this explainer.